Hi everyone. Today I'm going to be showing you how to make a Christmas tree ornament PCB like the one you see here. There's no electrical engineering, circuit design, or PCB design experience required. All you need is access to a computer, and we'll work on this from scratch. You can see on the front there are LEDs and resistors, and on the back there's a CR2032 battery and a switch. It's a little hard to see over video, but when it's turned on, it looks like this. Okay, so to create our first PCB, we're going to use an online tool called EasyEDA. So go ahead and go to easyeda.com/editor. And this screen will pop up. You should go ahead and register for an account if you don't have one, and make sure you're logged in so that it can save all your work to your account. So the reason that we're going to use EasyEDA instead of, for example, KiCad or any of the other free tools for creating PCBs is because of the library of parts. So EasyEDA is created by the same company that created LCSC. And LCSC is a components company, and so they have a ton of components for PCBs with amazing prices. It's very similar to like DigiKey or Mouser, if you're familiar with those, but you can find almost anything that you need in their libraries. And the nice thing about their products is that, for example, if we just choose any random product and click on it, basically they have a data sheet, but they also have a model. So when we actually create our PCB, we need footprints, and their libraries, every component already has a footprint. So we save a lot of time having to create, footprints for a ton of different components just by using their community of people who constantly are creating components for the parts. Okay, and the other reason is because they are also the owners of JLC PCB, which is one of the places that we can manufacture our PCB. And they have some of the best prices compared to like the alternatives like PCBWay. So those are the reasons we're going to use EasyEDA, and I'll just go ahead and start with our Christmas tree ornament. So I'm going to name the project tree just to keep it simple, and I'll save, and you can see the folder is created here, and it immediately opens up a schematic file. So the schematic is the symbolic representation of our circuit. It's where we define all the components and the connections, and it's all the conceptual part of the circuit without any of the physical components and connections. So it's really important that the schematic is accurate and it looks nice, because this is what people will use to reference your design. So I'll just go ahead and start. We're going to place our first component, and what we'll do is go over to the EE library, and this has a bunch of the most common components that you'll need for just basic PCB design. You can also create your own components. These are symbols, and we'll go over that in a future video, but for now we won't need any more than what they have here. So first we're going to go for a battery. In most of our PCBs, we're going to use a coin cell battery, and the most common is the CR2032. So I click the drop down and I choose the CR2032, and then I click the component symbol, and it shows up, and I can drag it around anywhere that I want before I place it. But first, and I'll zoom in a little just by scrolling in, I want to, just for convention, keep the positive terminal on the top, and that is represented by the longer bar and the pin 1. So I'm going to rotate. You can see it's on the bottom. And to rotate, I'm just clicking R. And now that the top terminal is terminal 1, I'm going to go ahead and click to place. And you can see that I can place as many as I want, but because I only want one battery holder, I'm going to click the escape button on my keyboard, and now I'm free of that. So like I said, in order to zoom in and out, I just scrolled. You can also use these buttons here, or if you get lost, you can just zoom fit. And then to go left and right, I use the arrow keys on my keyboard. So we have our first component, which is a CR2032 battery. This is a coin cell. And next I'm going to place the switch. And here we have the switch that we would like. And so I'm just gonna click it and place it like so. And I can place it anywhere I want. It could have been over here or over here, but because it has no bearing on the actual physical PCB that we're going to design later. Again, we're just showing the connection, so it makes sense that we connect the terminals directly. So now that our switch is placed, we are going to add the last two components, which are the resistor and the LEDs. So we'll do a resistor in the US form. So this is the US resistor symbol, and then this is the European resistor symbol. It doesn't really matter. Again, it's symbolic, but we will use this. And then if you've ever worked with PCBs before, there's two main types of components. There's surface mount components, which are here, and these are the common package type. So these represent the size of the surface mount components. And these are the through hole components, and these are their respective sizes. So surface mount components are the ones that lay flat on the board. Through hole components are the ones that go through the board and are soldered by hand directly on. Surface mount components are usually put in the oven and soldered that way. So the most common type of resistor is a 1/4 watt resistor. That's what you'll find if you are in the lab or makerspace most commonly. The next most common is probably like a 1/2 watt, but for now I'm going to select the 1/4 watt. 0.4 represents the lead spacing. So this is the space between the two metal leads of a resistor in inches. So I've selected that, and now I'm going to put the component on, and I'm just going to place it like so. And we are going to have 6 LEDs and 6 resistors in the project. That one is a little out of alignment. Like I said, if you do make a mistake, it's easy. You just click and drag. But you do want your schematic to look nice because a lot of people will be looking at it. It is the main way to look at the design. And next we're going to do the LEDs. So here you'll see that the options are, again, the surface mount and then the through hole. And we are going to use 3mm LEDs. And ours are fast flashing LEDs, so they're not really RGB. So just go ahead and click any and rotate it so that the cathode is facing down. The cathode of an LED is this line at the bottom. It's the negative terminal, and it needs to be connected to the negative terminal of the battery in our case. So LEDs and resistors are different in that resistors, both the terminals are the same. So it doesn't matter. I could rotate this and the circuit would still work perfectly. If I rotated one of the LEDs, it would be catastrophic. There would be no current flow on this branch because that's not the way LEDs work. And you can see that now that we've placed all of our LEDs, it looks not great because of the overlapping labels. So you can move the labels around, and then this is the description. Usually you will have something about, here we have the resistor is a 1 kilo ohm resistor, This is the battery type, and then more component information. In this case, we don't actually need any of the information other than the 3 millimeters. All of our LEDs are going to be the same. If you had different LED types, it would really matter. You would have to label them R, G, or B. All of ours are the same in this case, so we don't really need to label them as different. So I'm just going to go ahead and shorten the label in this case because it will make the schematic look much nicer. Okay. So now that we've done that, the great thing is that there's a lot of shortcuts that'll make this schematic work easier. So if I delete this resistor and I don't want to go back into and find the component, I can just Command C and Command V, and you'll see that the resistor pops back up and I can place it. Okay, so we've laid out all of our components. This is all that our circuit includes. And so now we're going to wire it up. So I clicked on the wiring tool, and you can also use the hotkey W. So escape, I just hit escape, and I can hit W, and now I'm in wiring mode. So you'll see that I'm about to connect up a component, and the black dot that shows that it's getting connected directly pops up, which is great because, you know, if you think you're connecting something like this, you won't see the black dot, so you need to make sure that it's always being directly connected. And we're going to connect here and all the way down, like so. And it's important to see, you see the 3-way dot, so you know everything is connected. The schematic is like the ground truth for your circuit, so it's super important you get it right. And then finally, we're going to do the same on the bottom for the cathodes, like so. And now that we're done with that, the circuit is effectively complete, but there's a couple of other things that are super important that aren't necessary, but definitely make your schematic more advanced. The first is the fact that we're using the switch as an open circuit to turn off all of the LEDs. So you see when it's in the mode 1, or the first mode, it is connecting and current will be flowing and our LEDs will be on. In the other case, we want this to be open because it'll be an open circuit, so no current will flow. And so right here, we're going to click the X, and we're going to have the X there, which symbols a no connect. So if someone's looking at your schematic, they might think, oh, this is a mistake, you meant to connect something to this. But if you put a no connect here, it's like, no, this was intentional. I don't want to connect anything there. So that's very necessary. And also, we're going to put no connects here and here. Some switches have leads that are connected to the internal circuitry, so we just want to symbolize that ours will not. Now, finally, another important step is to add power and ground symbols. So this is the positive terminal of the battery, so we're going to label that VCC. And then it's always important to have a ground in your circuit to symbolize the lowest voltage level. And now our circuit is complete. So this is all our schematic needs to have. There's other things that you can do. You can add labels and separate the circuit. You can create net labels so that you don't have to directly connect wires and instead can show the wire connection via a label. But for now, we're just going to keep it simple. So we have our symbolic representation, and we should go ahead and do Command S for save so that all of our hard work gets registered. And now we need to connect the symbolic representation of our components to physical representations. And so the first step of that is actually picking the parts. And this is probably the most time-intensive aspect of PCB design, is picking the actual components that will go into your device. And that's another reason why I like Easy EDA, because you can go through LCSC and pick the parts from their database. So the first part that we need to find is the battery. So we're going to look up CR2032 battery holder. And you'll see that it found 2,000 parts, which is more than we'd ever be able to get through, but you should always first sort by the category. It should be very obvious what category is in. We're not looking for fuses, we're looking for battery connectors. So that's only 232 results. And then I always immediately look for in-stock components, and I sort by the price, because they'll often put much more expensive components first for some reason. And then you can look at the pictures and kind of decide what you want. I find that you'll usually find the component that you want on the first page, but sometimes it takes a little more digging. In this case, this is the component that I chose. You can see it's super cheap. You can have 10 of these for 7 cents. So we'll go ahead and click on it. And you'll see that there's a part number and an easy EDA model, which is the footprint. So let's open that up. Okay, so based off of the symbol, which is the same we used in the diagram, it associates the pin, so the positive terminal with this pin and the negative terminal with this pin. So you can see this is actually how it will look on our board, which is cool. So if I was going now, I would go ahead and add this to the cart because I've decided I'm going to get this, and then I'm going to copy the name of the component, and I'm going to go back to Easy EDA, and I'm going to go to the footprint manager. So you can see you can also click Alt F, but I'm just going to go ahead and click. And here, these are all of our components and the components and the symbols. And then on the right side, you can pick the footprints from their library. So let's start with the battery, and they actually already have associated it with the correct footprint. This is a very common battery holder that we've chosen, which is cool. And you want to look for that because that often means that they're cheap, but also very, very popular for a reason. They're easy to use, et cetera, et cetera. So we don't actually need to change it. I'll go ahead and show you. So we copied the name of the device and we'll go ahead and search it. And you can see that they actually already have it in the library. It's obviously the same thing. And so if this was something different, we would double click and it would say, okay, updated the component. The other thing is if you can't find it within LCSC, users contribute their own. And you can go through and see if any of them look similar to what you saw in the LCSC datasheet. So if they don't have an easy EDA model associated, you can look at the datasheet and try to figure out, okay, do any of these look right? If not, you can actually create your own, which I'll go into in a future video. But because we're using very standard components, there's really no need. Okay, so the next are LEDs. I have not found fast flashing LEDs on LCSC. So this is the one component that we will buy actually on Amazon. So we'll go to Amazon.com and you can go ahead and look up fast flashing LEDs. And this is the exact ones that we'll use. Okay, so these are standard 3mm LEDs, and they actually have their own schematic here. Oops. Okay, here. And so the important part of an LED is one, that it's a 3mm LED, and then two, it's actually the pitch width. So the pitch in this case is 2.54 millimeters. This is the most common pitch width, and that will influence which footprint we decide. It's just the important one for LEDs. So in this case, we have this footprint associated. This is actually the standard 2.54, and we'll go ahead and do a search. You can see that there is already a a footprint for it. Like we talked about earlier, LEDs are polarized, so connecting the LED to the correct terminal is extremely important for your circuit to work. And for that reason, we want to be very careful that the person putting the components into our board will be able to tell which one's the positive and negative terminals. And right now, the only way you can tell is by the flat bar at the bottom, which is supposed to represent the flat bar on the symbol. However, when I've used this symbol in the past, there's been issues with people not being able to tell just because the printing is not as clear and everything. So what we're gonna do is actually create our own footprint for this, just by editing the existing one. So go ahead and connect or copy the name here, and we're going to go into the library and search. Okay, and you're going to want to go filter by the footprint because we are changing the footprint. So you can see here, this is the exact footprint that we were looking at, and it's perfect. We can also look at the other ones. These are all valid footprints. You can see they even label the pitch as 2.54. That's something that you want to verify. So we're going to go ahead and click on the one that we liked and click edit. Okay, so here is the footprint, and there's something that we should go over first, and that is the layers. So on any PCB, there is a top layer and a bottom layer. And so your components and wiring will go on either of these two layers. You can create more layers in a PCB, but a standard PCB has 2 layers. And along with that is the silk screens. So silk screens are just the writing on top of each layer. So you have, for the top layer, you have a top silk screen, and on the bottom layer, you'll have a bottom silk screen. Those are the important layers for now. And you can see that this is on the top silk screen. So this is just the drawing of our component on the top of the board. And for a user to be able to tell that which lead goes in which hole, we want to add text to show them which one is the positive terminal. So I'm going to switch to the top silk layer so that I can add text that will show up on our board. And then I'm going to actually click on the wire tool so that we can draw something. Now, you'll see I'm actually not able to click right here with this wiring tool. And the reason is actually because of our grid size. So go ahead and change this to 0.1 and then also to snap 0.1. Oh, and now you can see I can draw wherever I want. So right here, just drawing a small, and then, okay, so I clicked down, escape, and now I'm gonna do it again. Down, escape. Okay, so now we have added text to show which is the positive terminal. This will be our through hole. This is the second through hole, and now we know which one's positive and negative. So go ahead and click save, and it's going to let you change the name. So in this case, you could name it the same thing, but because we're actually not using red LEDs, we're using fast flashing, I will go ahead and save it as this. Okay, I've actually already made this before, I guess, so it's giving me an error that I already have something under the same name. You should be able to save yours and then just move on. So I'm just gonna close mine out, but make sure yours is saved. Okay, so now we'll go back into the footprint manager and click on LED, and we'll search for the name of the LED we just clicked, and it'll show up. You'll see it's under the name of your account, and you'll want to switch all of your LEDs to that name. So we have a perfect footprint with a delimiter. So in order to change them all at once, click on the top one, and then hold down Shift and click on the bottom one, and it'll highlight all of them, and then you can just change them all at once. Perfect. Now for the resistor, actually we are using a standard quarter watt resistor, and so the default 0.4 actual resistor footprint will work perfectly for us, so there's no changes that need to be made. And then we will go find a switch to use by going to switch. Actually, we can just go to the switches here, and we will do slide switches, because that is the type of switch we're looking for. Tactile switches are more buttons. We want to sort again by in stock, apply, and then pricing, we will again sort by lowest price. And off the bat, any of these will really work. I think this is the best one, and you can see we will get 20 for 2 cents. So I'm going to click on this, and you can see it has an easy EDA model and everything. So it will go into our board. You can see there's 3 prongs and then 2, I guess, supports, and it will go into our board horizontally and stick out of the bottom. So here you can just use this, and we will, so I've copied the name, and I will search it here. And you can see there is a component, and this looks consistent. So these are the 2 supports, the 3 pins, and you can see based off of this outline that the component will hang off horizontally. So you're gonna wanna double click, and you can see that it got updated here. And now before we leave this, we just wanna go through and make sure that every single one of the components looks correct, so that they have the correct footprint associated and that we didn't accidentally forget to update. So I will go ahead and close out of this. And there's one thing I actually forgot about the schematic, and it's actually that we have the wrong value for resistors. So super important that this is accurate, because if someone tries to build your board without you giving them the components, it needs to be correct. So we're gonna go ahead and change all of these from 1 kilo ohm to 100 ohms, because that is the correct value of resistor that we should be using for our circuit. Sorry about that. And so you want to make sure everything else is correct as well. And you can update the text here to have our exact part if you'd like, or you can do something like single pole double throw, which is or slide switch, anything that describes what this component is here. And then this has the CR2032BS21, which is correct. And now we're pretty much done. So I'm just gonna go ahead and hit Command Save. And now that we have the symbolic representation connected to physical representations of each part, we can design the actual PCB. So go ahead and do Design, Convert Schematic to PCB. And it's gonna go ahead and open up a new file, and it's gonna ask you if you wanna create a board outline. So the reason this is cool is if you're just creating a bunch of boards and trying to do things quickly, you can easily create a board outline. You're gonna wanna do round rectangular probably, because when they fabricate the PCBs, the edges are super sharp and you don't want to cut yourself or hurt someone with it. So I suggest doing round rectangular. This is the corner radius. And then just go ahead and set the width and height of the PCB that you want. I'm also going to show you how to do a PCB outline in Onshape. So you can import a PCB outline with out of any DXF file that you have or can create. So you can create that in Onshape, like I said, that's where I create them, or you can create them in Inkscape. In this case, I created a tree outline in Onshape. I'm not gonna lead you through that. I'm gonna learn how to create more complex shapes. There's a ton of online tutorials for Onshape. It's an online free tool for students and educators, so you should be easily able to create a free account. And so I'm just gonna go ahead and delete this default board outline, and I'm gonna go to File, Import, DXF, select DXF file, and I'm gonna drag my tree that I've made. And you can download this tree.dxf file in the comments below. And once you have this, you should be able to see it. It should look accurate. You shouldn't be able to see any holes or anything. And you wanna make sure that your units are in millimeters. So when you create something in millimeters, you wanna make sure that you import it in millimeters, or else the dimensions will get really warped. And you want to make sure you put it on the board outline layer. So we were talking earlier about the different types of layers. There's the top silkscreen layer, which we talked about is just a bunch of drawing lines on the surface of your board. You want this to represent the board outline. And so you always want to make sure your board outline, you have a board outline, or else you will be just designing an infinite sheet of PCB, which you won't be able to manufacture. And I've just placed it here. And you can see that we can bring our board outline, this is the layer manager, in and out of the picture by clicking this. And the layer that we're currently editing is actually shown with this pencil. So these are all the visible layers, and this is the current layer that we're editing. And that's super important. You want to always make sure that you know where you're editing and everything. And just in general, know how you can use the layers to your advantage. The reason this is important is because for some components like the battery and the switch, we're actually going to put them onto the bottom layer so that they are on the back of our board. So let's just go ahead and start. This component set is actually called a rat's nest. The reason that is because when we first create the PCB, these show up with a bunch of connections. You can see these lines. I'm sure they're faint, but as we move them around, the lines always stay connected. And the goal of this PCB design is to make sure that there's none of these left because we've connected everything. So there's no outstanding connections to be made. And so for now, let's just go ahead and start placing. There's a lot of creativity involved in this process. I'm just going to start with LED 1, and I'm going to place them in the corners. You're welcome to use a different system, but this is what has worked for me. I think it looks good in the corners, but you're welcome to change that up. Okay. And I just want to reiterate that, you don't have to do everything perfect the first time. If for some reason you've made a mistake on the schematic and you realize you have to go back and fix something, like let's say I forgot a 6th LED and resistor, all I would do was add them back, and then because I've already converted the PCB to the schematic, just do update PCB. And it'll show you a list of changes, and you're just going to click accept. So don't worry if you've made any mistakes so far. It should be very, very easy to fix them. And now we're just going to keep going. Make sure you always keep your schematic and your PCB consistent. So if you make a change to schematic, always update the PCB because it's necessary and it's the ground truth. And now I'm just going to put the resistors. I'm dragging and dropping everything. I'm going to put the resistors next to the LEDs. So LED 1, resistor 1, I'm going to rotate. And you can use this green dot to kind of spin them to be wherever you want. So I'm going to put this here. And these are supposed to represent like sort of ornaments. They're just supposed to look fun and everything. So I'm just putting everything where I think it should be, but you're welcome to change that up. So, and and I'm clicking R for rotate. So go ahead and just place your components. Hopefully it should be clear so far. And make sure you're on the top layer again. That's really important. And we're placing that there. And my last resistor will go here. Okay, so I have all the components on the front. Now I'm going to click here to start editing the bottom layer. And the reason that is because I want to put the battery, which is currently, so if I click the battery, I see the components and I see that it is on the top layer. And you can see that it is represented in yellow. So it's a little more clear when we're on the top layer. It's bright yellow. When we're on the bottom layer though, we want to switch it to the bottom layer so you can see it switches colors. So on the top layer, components are yellow, on the bottom layer they're green, and also the text is backwards. That's because when you have your text backwards, from the front it looks backwards, but actually if you look at it from the back, it'll be correct. So now we can put this here. And make sure all of your components are within the board outline. If you go outside, then your component will hang off the board, which is fine, but is probably not correct. And even though these are on different layers, you don't want the hole overlapping with the battery holder, because you won't be able to put the resistor through that hole if you accidentally put the battery in first, and it won't be able to lay flat because you have the solder poking out. So I'm just going to move this a little bit, even though it's technically still fine. We just don't want it too close so that we can actually solder everything correctly and not worry that people will make mistakes. And we want to do the same thing with a switch. So the switch is going to go on the bottom layer, and you can see it just turned green. And I'm going to have mine hanging off the board so that you can actually see this and slide it very easily. But really it's up to you. You can move it back, do whatever you want. So here is all of our components laid out. I think it looks great. And you're going to want to start wiring up. So let's go back to the top layer. And this top layer is the thing that everyone will see. So I'm going to concentrate most of the wires on the top layer just to give it a PCB feel. And there's no right place to start in our case. You know, if your circuit is very complicated, you might want to start in the most important place, but ours is not complicated. And so let's just go ahead and start connecting stuff. So you can see this, when I click there, oh, sorry, I should start by saying, in order to do the wiring tool, you can either click this or you can hit W again. So I'm clicking on the pad, and you can see that there's a bright white wire showing where I should connect it. And this actually, the connections change based off of their location. So even though, you know, this is showing it should be connected here, this actually is always there. But if I move this around, this connection would actually change because these can be connected to any of these. So if I connect this one to this one, it's correct. Or if I connect this one to this one, it's correct. So the actual wiring suggestions will change based off of location, but for now, I'm just going to go through and try to get everything connected. And let's see. And you can move things around. So if you think, oh, here, let's find an example. Okay, so this is supposed to connect to here, and this is supposed to connect to here. So in order to actually make this easier, let's rotate this. So you can see now that these two wires don't cross. And so I'm going to go back to the wiring tool, and now I can route this up here easily. And make sure you don't wire outside of your board outline, or else none of those wires are connected. The other thing is that if I try, so here, if I try to connect, so I'm trying to get down here, right? This one wants to be connected here. if I try to pass through a wire that it's not supposed to connect to, aka this one here, the tool actually won't let me. And that's because these wires conduct electricity. If they connect to each other, then they'll actually be connected, which is incorrect based off of our circuit diagram. So what you can do instead is either you can go around, and in this case it's super easy to go around, right? We just go here and then we go here. Or I'll show you another technique as our board gets a little more complicated. But first, let's just keep wiring. And you know, if you decide that your design is, you know, not good enough, you can delete all of the wires and just start again. That's always an option. It's somewhat like a puzzle. So, you know, you'll be connecting things. Oh, I thought those two were supposed to be connected. You'll be connecting things and you'll realize, oh, there's a better way to do it. That happens a lot when I'm, you know, making a PCB. Is I'm like, oh, you know, if I just laid out the components this way, it actually would have turned out a lot better. And so I go through and I redo the whole thing, and that's okay. And so don't be too hard on yourself. So this one is going to go down here. And you'll see I need to connect this one here, but actually there's a lot of wires, and I could go down here and then go around, but that would be a lot of work. So here's where I'll show you the second trick. So if there's nothing else you can do, you don't want to relay out the board, you don't want to move components around so that you can connect things directly, what you should do is you should set a wire, and you should click here right before the wire that you don't want to touch, and then click V. And this will create a via, and you're gonna wanna, so you can see that there's a dot created on my mouse, and I'm just gonna click right on the wire that I was working with, and I made a mistake. So I'm gonna click escape, and I'm going to delete this via, if I can. Okay, and I'm gonna click V again and redo it, and you can see now it's connected. That just meant that the via didn't have any net before, so I'll show you again. So before I clicked like right there, so you can see it's not connected, and you can see if I click on the via, the net is left blank. So I'll delete it, and then I'll do it correctly, and you can see it is not X'd out and the net is correct. So a via basically connects the wire that we're making on the top layer to the bottom layer. So now I can actually connect to this via and wire on the bottom layer, which goes around the wire that we're trying to avoid. So what I'll do is I'll switch the bottom layer, I'll hit W for wire, and I can connect to this via. And see, I'm routing under the wire that we were trying to avoid, and either I can connect directly to the pad, or I can create another via. Oh, oops. Sorry, let me redo that. Wire, so I'll start the wire, and I click to end the wire, and then I click via, and I can create a via on that wire that connects now this bottom layer to the top layer, and now we can finish our wire by connecting it right here. Oh, oops, sorry. Okay, that was actually an interesting mistake. I'm on the bottom layer, which means I cannot connect. So now I can connect to the top layer. Perfect. So that is how you create a via, and it's just for when you're welcome to use it whenever you want, but it's just for when you cannot directly connect things. So this I can directly connect. This I can also directly connect. Let's see what's left. Okay, so there's a bunch of connections left. So just finish up wiring your diagram. You'll know you're done when there are no rat's nest lines left. There we go. Oh, that's a really bad wire. And try to keep your wires elegant, I would say. There's a lot of rules to wiring. Like, technically, you shouldn't really have any right angles and stuff. It doesn't matter because this is a very simple circuit, but in a professional scene, you definitely want to make sure your wires conform to standards. So I'm gonna go ahead and connect this there. That's also, any acute angles are not good, but it's okay for now. Okay, and then this is the last one I have to connect. I'm probably gonna have to do a via. Yeah, so here, and click V, select down, the via looks great. I will switch the bottom layer, click W again to create a wire, click, create another via, and place it on the wire, escape, and then switch the top layer and finish up the wire. Looks great. Okay, so I believe everything is wired up. I don't think it looks great, but I'm satisfied and it seems like everything is connected. So that is all that matters. I just saved it. Now, aesthetically, everything on here is going to show up on our final circuit, or sorry, our final PCB. And honestly, the LED labels, you could move them. You definitely want them on the board, or else you'll just have like LE and the D will never get printed. However, since our LEDs are all the same and they're very obviously LEDs, I'm actually just going to delete the labels for LEDs. You're welcome to leave them on and just make sure they're on the board, but I don't think that they're necessary for this circuit. And then for the resistors, they're also not really necessary because all of our resistors have the same value, but I'm going to leave them and just put them, inside of the resistors so that when we actually put the resistor on top, they won't show up. And this is the last one. Oh, sorry, there's two more. There we go. And there we go. Okay. Now we're good. So this looks great. And if you want to view your PCB, this is one of my favorite tricks. So go ahead and save. Click on 3D. So this is the 3D view of your PCB. This is how the wiring will look on your PCB. You can see our little vias there. These are the LEDs and everything. And you can also even check out the back. Here's our battery holder and our switch hanging off the board, which looks awesome. So, and you can see this is the silk screen that I was talking about. So the white lines are the silk screen, and you can kind of see them outlining the components. Go ahead and click out of that when you're done. Now is my favorite part. You're gonna want to, I guess, personalize the board a little bit. So what I did on my original board is I switched, so open up the layer manager, I switched the bottom silk layer, and I added text that says, and you'll see it'll show up backwards, and that's okay, that is intended. This is a ornament, so you're going to want to make it maybe even a gift. So I'm going to print Merry Christmas here, and I'm gonna put it here, and these will not actually overlap because this is on the front, this is on the back. You can click on it, you can change the size, the font, anything that you want. And you can even add images. So if you'd like to add an image, I'll go ahead and add a image. Select an image file, and you're gonna want to play around with this a little. It's more complicated than it looks, but because I have a very simple SVG, it will turn it into a bunch of lines, and you're gonna want to play with the color tolerance and the simplified and everything and the size. I'm going to switch this to millimeters, and I'm going to make this much smaller because we have a very small PCB. And even that is probably a little too big, but we'll try it anyways. And try to avoid the holes because your text will not appear. So I'm going to overlap with it a little, but I think that looks good. So if you want to see it again, I'm going to do 3D view. And this is the front. And now this is the back, which looks sick. Cool. So that's good. Now it's an ornament, which means we're gonna have to add some string to hang it on a tree. So you're gonna wanna switch, we're currently on the bottom silkscreen layer. If you'd like to add to the top silkscreen, so the top silkscreen, we saw in the 3D view, it looks like this, and you know, there's what's currently on it is like the resistor outlines and everything. You can add like little image ornaments or more text, whatever you'd like. And we're going to switch the board outline layer because we want to add a hole right here for the string. So we don't want a pad, sorry. We want a circle, and oh, there we go. So you're gonna click and then drag to the size. I think that's probably good. Escape, and I'm going to move it to the center. Now we can string through this to create a real ornament. Okay, so now that our PCB looks great, we're going to have to verify that everything is correct. So go ahead and make sure you save your design. You don't want the little star there that shows that it's unsaved, and do check DRC. So this is a design rule check. And all it does is, all it does is make sure that that everything meets the manufacturer's specification, everything is connected as expected, and everything like that. And you can see that ours does not. So it's saying that the ground net has an issue. So these are the DRC errors and then the net errors. And when it shows that, it means that we've left something unconnected. So let's look. It's a little hard to see. Here we go. So you can see I've missed actually a wire, and so I'll have to route this. So I'm gonna go ahead and hit W and wire everything. And I'll need to use a via here. Oh. I will have to redo that. You can see it's not on there right, so we'll go ahead and add a via there. Switch the bottom layer and wire this, and I'm just gonna go directly there. Okay, so I think that is the last part that I've missed. I'm gonna switch back to the top layer. And if you ever want to look at without like the top silk screen or the bottom silk screen, sometimes looking at it without the bottom components is easier to see. Feel free to switch those off. It doesn't mean they're not there, it just means you can't see them in this mode. So it's sometimes helpful. And now we're just gonna make Command S, so our changes, import changes, and you can see that the design rule check is now clear. We'll do check DRC again, just in case. And everything looks good. Okay, so now that we've verified that our PCB doesn't have any DRC errors and that everything is connected, let's go ahead and order our board. So go to File, Generate PCB Fabrication File, and run the DRC check again always. It's just safer. And you can see our PCB looks great. It will let us actually order directly from JLC PCB from this window. And the minimum quantity that you can buy is always 5. So you'll get 5 of these PCBs for your friends, family, your tree, anything. And you might want to change the color of the PCB. Obviously, trees are green, so you should just leave it default because green PCBs have the fastest assembly time just because it's default. And then the rest of this is standard, and JLC PCB definitely has the best prices that I've seen. And then the shipping costs are slightly higher. They're anywhere from $7 to $12. Just make sure you choose the cheapest one and you'll usually get it within 1 to 2 weeks. If you don't want to order from JLC PCB, go ahead and click Generate Gerbers, and then you can input these Gerber files, the zip file, into any website that manufactures PCBs and order from them. PCBWay is a great option, and there's also local options as well that you might have. They just tend to be a little more expensive. And after that, make sure you order your parts. So go to LCSC and order all of the components that we were looking at, including the battery holder, the resistor, and everything. The prices are great, and you will also have to pay a little in shipping, but hopefully you can keep that low if you do a longer shipping time. And then you just wait for the components to come back, and once they do, you can start soldering it up. And hopefully it's easy. I'm happy to post a video on soldering up these boards. And I'm also going to post more videos in the future on other projects that I've worked on, including a PCB Game Boy, a Halloween PCB, a Valentine's Day PCB, and other fun things. But I'm also open to suggestions. So if you like this video, feel free to drop a comment on what PCB you'd like to make, and we can make it together. Thank you.